Okay, let's take a look at division of polynomials today. First, we'll take a look at divisions of polynomials by monomials. Okay, so to do this, there's basically just one step. You divide each term that's in the polynomial by the monomial divisor. Again, this is way easier to see with an actual example. So if you have something like 3x minus 6, there's a polynomial. It's a special one called a binomial, and you divide it by the simple monomial 3. What you're really doing is taking the first term and dividing it by 3, and then you're taking the second term and also dividing it by 3. 3 divided by 3 is just 1x, and we don't write the 1. 6 divided by 3 is 2, and you have your answer. When you get good at this step here isn't needed. Okay, let's take a look at another example. Okay, so for the second example, let's do a little bit more complicated polynomial on the top. So 15x squared y plus 30xy plus 75y all gets divided by 5y. So try this yourself. Pause the video now. Try this yourself and see what answer you come up with, and I'll do the answer in a couple of seconds. Okay, so you should get 15 divided by 5 is 3. X squared y divided by a y, the y's cancel, so you get x squared. And now 30xy, that middle term gets divided by the bottom term, and you get plus 6. The y's cancel again, so it's x. And 75 divided by 5 is a little bit tricky. I believe it's 15, and the y's cancel, so it's just the number 15. And of course, we always want to double check these for degree order. So if you're adding little notes on, I'm not going to put that in here, but you can write yourself a little note to double check things are in degree order for their final answer. Okay, let's take a look at an example of how to use this with algebra tiles, and I'm going to need a little bit more space to do that. Okay, so in an example using algebra tiles, let's take the example 4x squared minus 6x is going to get divided by 2x. So what's given to me is this polynomial on the top, this binomial, and that's going to include 4x squareds. So if that's 1x squared, and there's another x squared, and here's another x squared, and here's another x squared, and minus 6x, 1, 2, 3, 4, and I've done these in a fairly necessary order, which will be given to you. So this picture will be given. Don't worry about designing that picture yet. What I'm really worried about is that geometry, or that area. So in one direction, this is really equal to, oh, and no bad jokes about one direction being a bound. This is equal to 2x in this direction, and the question is, what's this one equal to? So division is the same as, or the inverse application of multiplication. So if I took 2x and I multiplied it by something, I should get 4x squared minus 6x. So if I take 4x squared minus 6x and I divide it by 2x, what I'm trying to figure out is what's this missing side. And that missing side's geometry is a positive x and a positive x. So x and x give you an x squared, and x give you an x squared, and you get all these 4x squareds. And then this is a little bit tricky. These are negative 3, because a positive times a negative will give you these negative x's, and so you'll get your negative 6. So you can see on the outside of this rectangle, I'm really just measuring the length and the width, or I've been given the length and I've been given the area, and I'm measuring the other dimension, say the width in this case. And so the answer to this, just from the algebra tiles, is, now I just read it off of here, there's 2 x's and there's negative 3. If you want to go ahead and verify that by doing the division that I showed you before, you can, but if you just read right across the top of this rectangle, you get your answer as well. Okay, that's it. We'll see you in class.